Good morning everyone, Shahin is here. This is a postponed online lecture on cost risk analysis and finalizing the project. On behalf of those present, I acknowledge the Wurundjeri people of Kulin Nation who are the traditional custodians of the land on which we all meet. I pay my respect to their elders, past, present and emerging. I also pay my respect to all Aboriginal and Torres Strait Islander people of Australia and hope that the path towards reconciliation continues to be shared and embraced. Okay, risk management. This is a process. You have to identify the risk for the project, and that is obvious. This is one of the things you want to plan for it, to get prepared for it and have solution, not to just come up with surprising during the project. So sometime you have heard about the acronym WHS, that is work, health and safety, or some people call this occupational health and safety. So these are some key component of the risk for every project, but the project risks are not limited only to these. There are other dimensions of the risk which we want to elaborate today. So how does this relate to your project? Well, apart from the WHS, OHS things, the other risk of the project, you have to identify them and include them in your project plan such that you can control the risk, you can prevent the risk, or you can reduce the impact of the risk. Let's see what the risk can be analyzed. So every risk on a project, whether that's a health issue or that's a finance or this is a technical risk or any kind of the risk, there are two key dimensions associated with it. First of all, that is the probability of the risk. How probable, how likely that risk is going to happen. Okay, so if you want to consider every risk, very soon you find out that your project is just consuming all the resources, getting prepared for the risk, but maybe those risks are not very likely, they are not very related to your project. So you want to make sure the risk is likely, that's a real threat to your project. And the second dimension is the impact of the risk on the project. So in worst case, if that risk happened, how that is going to impact your project. Okay, so all right, so once you identify a risk item, two scores we're going to associate to the risk. First of all, that is the likeliness of the risk, that's the vertical axis. The second is the impact of the risk on the project. And depending on the score, from very low to very high, you give them a number, something. If the probability is very low, if the impact is very low, you give the score of 1. And if the probability is high or the impact is high, you give this a score of 5. And once you give all the dimensions in a horizontal vertical axis, then you find some of the risks which are very unlikely, very minimal impact. So these are being colored in green. The risk item which are scored anything in between, so yeah, they are being colored either yellow, orange or red. So green being minor, yellow being moderate, and orange is a major risk and red is a severe risk. So you know that the way you deal with a severe risk is very critical, that you need to have well prepared. It deserves some good amount of the resources to be allocated to prevent or to mitigate it. And something which is minor, well, yes, you have to be prepared for it, but keep in mind that the importance. So that is a kind of simplistic assessment of the risk, because it's only relying on the probability and impact. So you might have other concerns which make a project more important or less important, and there are ways of accommodating them as well, something like a weighting factor. But before getting into that, I want to just provide a universal framework for the risk. So how the risks are classified. Okay, some risk we can eliminate them if we know those risks are possible. Sometimes you can eliminate them. Sometimes you can substitute the risk or hazard with a safer alternative. And sometimes you can isolate hazard from the people or reduce, and sometimes you can have some administrative control to reduce the exposure to the hazard. Alright, so that is the classification of the risk. So once we understand that, example of that, for example, the COVID, that was a risk to every project that impacted the way of life of many people in many different ways. But perhaps the way we can get prepared for it was by providing quarantine, work from home, using of the personal protective equipment. That is an example of a risk that you cannot eliminate. So you just try one of the other techniques if this cannot be eliminated. Alright, so now with the risk assessment matrix, this is the example I provided here, that is itemizing the risk first. So with your project there are a number of activities. So one activity for your project is you purchase some equipment, and then these are waiting for installation. So first of all, the equipment should be unloaded and then should be fitted to the ground by hold-down bolts. So if you break that into two activities, the first activity, unloading the equipment, the hazard it has is it's heavy. Anything heavy can fall, make injuries. So that is one hazard. So you can classify this risk as low because crane and lifting equipment are new. You do have some fresh and reliable lifting equipment. So what is the risk control measure for that activity? That is staff to wear hard hat, steel capped shoes, and stand clear. So you provide instruction to the staff. Okay, you provide them with get them prepared and make them aware of the risk. That is how you prepare for the risk. Second example, during the installation, the crash injuries, but again, That's a low risk because you want them to be using the protective equipment like shoes, hats, and just give them training for whatever they are doing. Now, as I mentioned, the risk analysis, two important factors are frequency or likeliness. The other score is the impact, severity of the score, and then you want to also associate an impact factor. Okay, so the impact factor is telling you that some risks should be treated more forcefully or more we need more resources than other type of the risk. And then when you are calculating the total score, this is not only the product of the likeliness by the impact, also you multiply them by a weighting factor. So now applying the weighting factor and two other parameters, you end up with some scores. So here a new design type has a very high risk score. So why a new design has a high score? Because you've never done it before. Many unpredicted things, you have to do research and development. You don't know the result until the R&D activities are finished. Okay, so that was just one example. But then you might ask yourself, all right, how this is going to impact my project? I mean, how this applies to my project? Okay, if you asking that question, that's a very good sign. It means you are aware that this lecture is not just a storytelling. So you have to reflect on these matters related to your project. That is to get you prepared for your future jobs. And for any project you're planning, this is something like a fortune teller. You have to predict the future. You have to predict what might go wrong with my project. What are the risks? If you know what the risks are, you are half the way through. You define the problem and then let's find a solution. But if you fail to find out a risk item, that's not a good sign. What it means is the risk is going to happen whether you predict it or not. But if you were lucky, if you were experienced, if you are prepared for a skill, that's good. If you were unprepared, the chances are some disaster or some loss. So as a part of the class exercise, I mean, this is a recorded session. I want you to, once you watch this video, spend enough time to identify the risk for your project. So just to help you with that, I can tell you two common risk items for every project, no matter what the title of the project. Two common risks are, first of all, you have to work long hours sitting next to the computers. That is when you do your 3D modeling. Once you are preparing the deliverable items, so everything these days we do them on computers. So the risks are having some connectivity issues, so you have to be prepared. Okay, I am backing up my files, so let's have the backup of the files so I can at least access the latest version of my file. Alright, so this is, everyone is welcome to include that risk item into their project plan. So this is going to be a bit too close to your week 11 presentation, which is this week, but definitely when you're writing your detailed group report for next week, you are expected to have a decent risk analysis and risk plan. So the fuel to that activity is, first you have to identify the risk, otherwise you cannot write your plan or write a remedy, eliminate the risk or reduce the impact of the risk. So let me repeat. One risk item that everyone can include in their project, that is cyber attack, internet disconnection, losing access to cloud data. So your cloud data are on Canvas. What if I don't have any internet? I can access the file. What if Canvas is dead? I don't have access to my data. So what is the how can you reduce the impact of the risk? Well, that is by having a backup of your file on a USB on your local machine. At least if the disaster happens, you still have access to the latest version of your file, so you don't have to start from scratch. Still, when internet is lost, when Canvas is down, you can work offline using your latest backup copy of the file. So that is one risk item. The second item is, if you are sitting next to the computer and working for a long time, there are back injuries, eye strains. So that is a risk. No matter what the title of the project, everyone would have that risk for their project. So how do you plan for it? So the plan is using some special anti-radiation shield or glass for eye strain, using proper ergonomical setup for your desk, computer, and also take a break between hours of working with computer. Just have a walk, take a coffee break and come back. So these are two common risks I mentioned, and they apply to every project. So other risks, like a member of the team doesn't contribute. What is your plan? So this is a risk, right? So that's not a safety risk, but that's a risk to the project. So what is your plan? If some people are irresponsible, if they are not collaborating, so you need to have a plan for that. Otherwise, you cannot deliver the project. So I think I made this clear that the risks are not limited to the safety and health. They could be much broader than this, different type of the risk. So the key is you have to identify the risk before you can make a plan to control them, eliminate them, or reduce their impact. Alright, so that is with the class exercise. You still have to spend some time reflecting on these related to your project. And now the next thing I want to bring your attention, it's not only the safety or health hazard, there are also project costs. So a project cost could be a major risk. What does that mean? You do have a certain budget. You are expecting the project to have some revenue, or you are borrowing money from the bank, and when you are giving this back, you have to consider the return on investment. So that means the project should be financially justified. If you haven't justified the project, if you don't know the product life cycle cost, the chances are you run out of the budget without completing the project, and that is something you don't want. You have to claim bankrupt, so you have lost your project maybe you would risk your business, and that is something you want to avoid by all costs, by all means. Alright, so now you realize that the project cost, if you don't have a clear understanding of the project cost, that is a real risk item. Okay, so how am I going to know the real cost of the project? So in a very simplistic approach, we can break the cost item into two categories. One is the labor cost. The second category is the material cost. So labor cost, you refer to your Gantt chart and look at the task. For every task you have allocated people. So from those, you can work out how many hours each person is supposed to work. And referring to the bill of material, you know what items are there, and you can work out the cost associated with those material either being manufactured or purchased from external vendor or customized after buying the off-the-shelf components. This is an example to evaluate the labor cost. So you are referring to your Gantt chart, and according to your Gantt chart, these are some items you identified. PCB design, this is an electronic project, so they have to work with PCB. This is a small electronic boards, and for that you need an expert pair to work on it, and he or she are spending 150 hours for that design. So how much you pay them? You're paying them $80 per hour. And when you need that money, you need that starting on January, and that would finish on the same month. So that single item would cost you $12,000 in terms of paying salary of the experts. Also, someone has to do the software design. So that requires two people. Anya and Paul should work on the software design. That you anticipate 200 hours is allocated to that, and they are being paid $80 per hour. Starting on February, finished on March. So that is $8,000 rise to the project. Housing design, testing, tooling, production, just to give you some example. And in the very same fashion, you can calculate the monthly cost associated with each cost. And at the end, if you add these all together, that is an estimate of how much money you need to pay the salary of the labor. This is not necessarily people within the team. You might pay this as a service to outside providers. Okay, but anyway, that would give you a rough estimate of how much money we are talking about for this project. Imagine you have to do all of these things at the start of the project. You haven't decided whether you want to go with it. Maybe at this stage you only want to provide the quote to a potential client. That is very tricky, and it takes experience. That is why experienced people get paid higher, because they have to go through all these things based on a prior experience to make a realistic estimate of the cost. And that is vital. If you don't have the realistic estimate, the chances are you would under evaluate a project. Okay, that's not good. If you over evaluate the project, well, that's not good either, because there are other competitors out in the market and they would get the project, not you. So you lose the competition. Okay, so like I said, the labor cost is evaluated in this way. What about the material cost? The material cost, you need to look into bill of material. Okay, so this is a sample bill of material or material list. So for every material, you have to source or find out a source as a provider, and maybe for finding these couple of different sources should be checked such that you get a competitive price. And then also you need to know when are you going to need that money. So you know everything at the beginning of the project. Some of them only you need them at a certain stage, so that would give you how you distribute the available funds. So not everything is purchased at day one. Some of them are purchased in the middle of the project, some of them Alright, so again, having all these items from bill of material or likewise, we can evaluate the cost associated with the material. Like I said, this is a simplistic evaluation. It is not only labor cost and material cost. There are many other costs you have to consider before you commit to a project or make a decision whether this project is going to be profitable, or you have to just decide not to do that project. Okay, so well, the other thing is you are borrowing money from the bank, and when you are giving that back, there are some interest. Also, what you purchase, there are some depreciation costs. Even at the same time, if you want to return it, that is not of the same money-wise, is not the same value. So I'm just giving you a flag that the calculations, you have to consider the interest on the borrowed money, and this is the formula. Don't worry, for your project I don't expect you to go through all these, but just be mindful that return on investment is not a simple thing. Sometimes you need to employ finance people to help you with that, but thanks to artificial intelligence these days, lots of these things you don't employ people to tell you about the return on investments. You simply ask this one from a generative AI system, and they do very good calculation for you. So you are reducing the number of costs needed to employ financial people or these type of works, as long as you know the background, you know the push and pulls of the return on investment. You provide detail specific to your project, and AI can do all this calculation for you, and now you are prepared to make a decision. So again, you have to consider the cost at the present, the future value. So again, these are very professional topics, but easily that profession can be replaced by AI. So imagine you have your own business. It is not necessary for you to employ someone to do this calculation for you. As long as you know the overall idea behind the present and future value, you provide the detail to an artificial intelligence system. They do the calculation for you, and now you have all the analysis you need before you make a decision regarding your project. Alright, so by now you have realized that a project requires a project justification. I know that the project you are doing is not for a mass production. This is for a client with a very limited resources. In these cases, the only source of income you can rely on is perhaps government incentives, subsidies, but in a real project, in a general sense, you're thinking of a project, a profitable project to be mass produced. So yes, that has to be financially justified. Otherwise, you cannot get committed to the project, or if you do, the chances are it won't be a successful project. So in order to do the justification, you need to know about the project expenses and incomes, and improvement on the current process and design, internal rate of return, capital equipment purchase, project saving. So capital equipment purchase is a critical cost item, and something like a software license, something like a special equipment you have to purchase, and then these are big monies you have to pay upfront, and that could be a real issue for a project to start. So at least you have to know their criticality, and when do you need that money? Yes, I need that day one, I need that in week one. Okay, every product has a life cycle cost. So what that means? Some costs are infrequent, something like repair, recalibration, recertification, rearranging, upgrade and updates. Some costs are regular, something like consumables, utilities, labor. You have to pay for internet, right? So that's a regular cost. You have to pay license fees, you have to pay for insurance, tax depreciation, financing costs, and also some costs are fixed, something like purchase price, end of life salvage price, delivery cost, installation cost, peripheral support equipment. So just be mindful the category of these. How do they reflect on your case? Okay, so for your project, it's whether this is for my unit project or for a real project you do once you graduate. So you have to understand the classification of these cost items. Alright, the last thing I want to cover for today's lecture is the presentation, which is this week, and then your group report, which is next week. So they do have a very similar rubric. All right, I'm going through these rubrics and make this clear for you that what are the expectations. So first of all, evidence of customer negotiation. I want you to itemize at least 5 measurable, verifiable need items. And also you provide a multi-layer mind map, which is a result of negotiating or discussing with a client. So measurable means something which is not subject to argument, not subjective to personal understanding of the problem. You want to make sure everyone is talking about the same thing, and that can be either ticked in the checklist or unticked. For example, my client wants something lighter than 5 kilograms. So you now made the project. Is this above 5 kilogram or below? Okay, no one can argue that. But if you include something, my client wants something durable, that is not measurable. This is not acceptable as a cost, as a need item. Excuse me. So, as a part of these, of course, you have to go through a number of concepts. So patent search is not directly related to item number 1, but that is when you are gathering a number of concepts. This is a conceptual design. That is when you understand the problem. So given that you know the problem, you are looking for proper feasible concepts. You go for the patent search, you go standard search, you have to find out about the legal limitations, laws. Imagine you are making a electronic upgrade kit for a bike. So you want to convert a push bike to an e-bike, and then your project is to make a kit. People can do it themselves. So okay, the client wants something very strong, very long-lasting battery, but it is a legal requirement by government. The e-bike cannot be stronger than 250 watts. So you might go and buy something with a 1000 watt capacity. That's not acceptable. So it is your responsibility to check for legal requirements. I want to see the minutes of meeting and brainstorming. The minutes of meeting should have enough details in them, including details of the activities. It's not just the attendance list. Okay, and next item is a table which shows a number of technical specifications related to the need items. So technical specification, these are the technical translation of needs. Needs are what the client put forward, and that could be in a layperson language, but a specification or translation of those needs. So you are expert, so you listen, you understand that need, you understand the problem, you translate that to some technical specification, and a table which show the correlation between this specification and those need items. Also, I want a Gantt chart, and that Gantt chart should have the 7 generic steps of engineering method. House of quality. I provided a template for you, provided some sample readings and theory. So that was a part of your weekly group submissions. If you work on the same submission and make these more elaborated, that is good for your week 11 presentation and for your week 12 group report. And conceptual design, at least 3 different feasible concepts. So everyone in the team is supposed to present a feasible concept with the detail, with the enough detail for the audience to understand what that concept is and how that concept can be compared to the rest of the concepts. So the major source of these concepts are from patents. Even though if you took it from the YouTube, I still want you to complete the patent search in order to get the skills of finding a systematic search for your future problem, for your future conceptual design. Design embodiment. So you want to convince the audience, the client, that only one of these concepts is the most feasible, is the best feasible to your needs, and you have to provide a systematic way of how these concepts were given a score, how were they prioritized, and then you choose the highest priority from that group of concepts. That is called design embodiment. That means you have made a decision with one concept, and the way you make that decision is systematic, it's professional, it's not just by one person's preference, it is a systematic decision. Then you go to the detailed design. So your detailed design, definitely I want to have a 3D model of your solution. That is an assembly composed of a few parts. So once you make that 3D model, you can extract the bill of material from that. So it doesn't make sense if you don't have a 3D model, then how can you make a bill of material? Okay. Also, that assembly would help you to make the tasks which are needed specific to your project. Also, I want the eco-audit report for your project. So you would use the bill of material from your 3D assembly to make that eco-audit report. I want the 3D model of the all components included in oral presentation as a exploded view with numbered balloons, animation of that, and sample drawing, not all of the drawing. Also, you are encouraged to choose one part from your assembly and have this one 3D printed. During the presentation, that 3D printed item would make a big difference. So you just refer to Mr. J.C. Wood, that's Jonathan, and ask him to give you access to the 3D printing lab for that. Or if you want to do it at home, if you have your own 3D printing, you're welcome to do that. Also, for your week 11, a brief cost and risk analysis is needed. And also, I will be looking at your Canvas group to find out that you uploaded the relevant file to your Canvas file folder such that all team members have access to it, and also your teachers can see who made what when, who updated the file. So that is a background check for your collaboration. I want to see the evidence of collaborative authoring. I already have briefed you on how you can initiate a Word, PowerPoint, or Excel document within the Canvas group tool. And other evidence of engagement in group are by looking at your announcement, at the ownership of the file, who generated the file, and when these were uploaded, completed. All right. At the end, if people are not happy with share or contributions, if some people did not take responsibility properly, you have a say. You're provided with a self and peer assessment form that is confidential. You can give a score to yourself and other team members. This is not mandatory unless you have objection toward the team member. I mean, if you don't complete that form, I take this as a sign that everyone contributed equally. So whatever score of the project, that is equally divided between the team members. But if you have an objection, you can complete this form and let me know. Then by looking at other people's peer assessment form, I can decide how the total mark of the project be distributed among the team members. Okay, so the next thing is a we did have a design competition ceremony, not this semester unfortunately. That was, I mean, people participated in the competition and 3 people are typically selected from that competition to be awarded certificates of being among the top 5 percentile of the groups. So now I want you to go back to your project, get prepared, making a material cost, labor cost specific to your project, and also making some identifying some risk items which apply to your project. Like I said, you can do the internet, COVID, eye strain, back strain, and how you are gonna tackle those things. And whatever your answers, share them with the rest of the class. Make sure you upload them on Canvas. So I look forward to see you all for this week's presentation when I provide you feedback on your checklist, on your rubrics, and then you can use that to perfect your next week's group report. Thanks very much. If any personal concern or questions, like usual, feel free to reach me by email or talk to me during the face-to-face session. Thanks and take care. See you all soon. Bye for now.